Yes, good morning children. Now we discuss the topic force and laws of motion. In this we discussed up to two laws. So second law of motion and its derivation F is equal to ma also we derived. Now we have to give a relation between momentum and the force. So the relation between momentum and force now we have to discuss. So relation between momentum and force. Momentum and force relation we have to observe. So momentum means what? Mass and velocity product. The product of mass and velocity is called as a momentum. Yes. Now force. So what is the relation between them means? Actual relation is force acting on your body is equal to the rate of change of momentum. So force acting on your body. Force acts on a body is equal to the rate of change of momentum. Rate of change of momentum. So rate of change of momentum means here initial momentum and final momentum. It's the rate of change of momentum. Means change in momentum with time interval to be considered. Rate of momentum with time interval to be taken. We get this rate of momentum value. That value is equal to this force. And universal formula will be there for this. What is that? F is equal to delta P by delta T. This application is also there. F is equal to universal force. It is called as a universal force we call. That is change in momentum, rate of change of momentum value. That is delta P by delta T is also one of the application. F is equal to delta P by delta T. Remember this one also. It is called universal force. Universal. Like that also we have to call it. Now, first of all, here we have to consider the change of momentum. First of all, mass of the body to be considered. Mass of a body is equal to m. Its initial velocity. To be considered as u. Now, momentum is equal to mass into velocity is the momentum. So it is also known as initial momentum. Write like this also. Initial momentum is equal to m into u. Initial momentum that is. Now final velocity of the body. Final velocity. So after traveling certain distance we get final velocity. Mass will be same. Understand, mass does not be changes by changing its velocity. Only velocity will changes by speed increases or decreases, changing velocity only, not for mass. So that's why mass will be constant and velocity change into v. Then final momentum will be m. Now change in momentum is equal to final momentum minus initial momentum. That is equal to mv minus mu. What is this? Change in momentum. Change in momentum is equal to mv minus mu. So rate of change of momentum is to consider with the time value also, to be taken with time. Okay, change in momentum. So rate of change of momentum is equal to mv minus mu by t. Now force is equal to, just below, force is equal to rate of change of momentum. That is F is equal to, so that is F is equal to mv minus mu by t. mv minus mu by t. So m is the common factor here, no? Now take m is common. m into v minus u by t. So to write like this also is application. So actual application will be this one. F is equal to momentum. Moment application will be this one. mv minus mu by t. But this can also be, from this also we can deduce F is equal to mu application. So how means to take mu is common from this, we get F is equal to m into mv minus mu by t. So we know that v minus u by t is acceleration. So a is equal to ma. Hence, why? Because v minus u by t is equal to acceleration. We know this, no? Rate of change of velocity is called acceleration. So v minus u by t is equal to acceleration. So we get F is equal to ma formula also. So from momentum application also, from force and momentum relation also, we get the application F is equal to ma. Okay. So this is about the relation of momentum and force. So actual relation to say momentum, force of a body is equal to the rate of change of momentum. Now universal force of the body to with momentum is given by application F is equal to delta V by delta m also we can write. Okay. So this is about this derivation. Now I have to say I can observe. So this is also one of the important relation by calculating the problems with applications. This one is very important one. Now we'll discuss about the force. So a force is a push or pull of an object that changes its velocity or direction. That's called as a force. So what is a force? Force. So force means, what do you say? A force is a push or pull. Push or pull. Whatever that. Either to push or to pull. We can compulsory need certain amount of force. If force is not applied, the body does not be change its position. Change its position means by changing its velocity or by changing its direction. So whatever that, to need certain amount of force compulsory. So force is a push or pull of an object that changes its velocity or direction. Now according to Newton's second law, what is the given relation? It is very very important. Newton's second law. So to remember, F is equal to ma. According to Newton's second law, it is F is equal to ma. According to that, go ahead and write the units of force. Now go ahead and write units of force. Units of force. So first one to consider in CGS system. In CGS system, what is the unit of force? So here mass will be gram, acceleration will be centimeter per second square, then force is equal to gram into centimeter per second square, or this value is equal to dyne, is also equal to dyne say. So gram centimeter per second square is also equal to dyne. So one dyne of force, it's a very very least force. Dyne force is very least force. Then later I'll explain that. So it's a very least force, dyne force. Understand how? I'll just write that. So 1 gram centimeter per second square is equal to dyne. In a CGS system, in MKS system, in MKS system or SI system to be considered, mass will be taken as kilogram and acceleration is taken as meter per second square, then force is equal to kilogram meter per second square. Kilogram meter per second square. This kilogram meter per second square is also equal to Newton. So to write simply N. So kilogram meter per second square. In MKS system to consider, in SI system it is said to be the Newton scientist names. We have proposed laws of motion, no? His name will be used. So in SI system almost all scientist names are used to remember. So by that to write that in names. As the unit, write only first letter of his name. Okay? Write the capital letter Newton. Okay? So kilogram meter per second is equal to Newton. Now this value should be considered. 1 Newton value is equal to 10 to the power of 5 newtons. So 1 Newton value is equal to 10 to the power of 5 times. 10 to the power of 5 times is equal to how much? 1 Newton value. So 1 Newton is equal to 10 to the power of 5 times. 10 to the power of 5 times is equal to 1 Newton. So 1 kilogram to convert into grams 1000. 1 meter per second to convert into centimeter 100. So how to get this value means to see. So to see here, 1 kilogram means 1000 grams into 1 meter per second is equal to 100 centimeter per second square. So 1 into, what do you get this value? How much? 1, 2, 3, 4, 5. So 10 to the power of 5 gram centimeter per second square. Gram centimeter per second square equal to dyne. That's why 1 Newton value is equal to 10 to the power of 5 dynes we have to consider. Okay? And this Newton value can be defined as a Newton is the force required to give mass of 1 kilogram of an acceleration of 1 meter per second square. So to change its direction or whatever that, the force needed 1 Newton means 1 kilogram of body, 1 kilogram mass containing body will be accelerated with 1 meter per second square acceleration. Then the force needed for that body will be Newton. That we can define the Newton. Okay. Now types of forces. Here different types of forces will be there. Types of forces. So mainly these forces are classified into two types. One is contact force and another one is force acting at a distance. So first one is said to be the contact force. Contact force. Two bodies will be in contact. That's said to be the contact force. And another one is said to be the force acting on direct force acts at a distance. Force acting at a distance. Force acting at a distance. So two kinds of forces we can classify. Contact forces. Contact forces means the forces will be very close together. Such a forces we call as contact forces. For example, muscle force, muscular force we call as, or otherwise biological forces and mechanical forces, frictional forces. All these forces are said to be the contact forces. To be contact, muscular force is used to push or pull the body. So frictional force, opposing force, some force applied on the body, it will be opposites means it does not be move, means certain force will be acts on that body also. Such forces we call as frictional forces. Now force acting at a distance means, for example, magnetic force, gravitational force, electrostatic force. All such kinds of forces is said to be the distance. Force acts at distance. For example, to see magnet will be placed here, there iron flings at certain distance. Means what happens? This magnet attracts that iron flings. Means here the force acts between the two, iron fling and magnetic force. So certain distance only it will be placed. This force will be placed. So gravitational force. This gravitational force is also a distance force acting at certain distance we have to consider. Okay. Now next one we consider Newton's third law of motion. It's a very important one. Newton's third law. Newton's third law of motion, or otherwise it is also known as action and reaction law. So this is also said to be the action and reaction law. So what happens? Every body has some act, means definitely some opposite force also acts on it. Remember that, compulsory. So when one body exerts the force on a second body, the second body simultaneously exert the force equal in magnitude and opposite in direction. Definitely another force that's called as a reaction force. For example, to throw the ball to wall, what happens? Again the wall pushes that ball back. So what happens here? Had thrown is an action, it comes back again will be the reaction, but in opposite direction. In opposite direction it will be acts. That's why action is equal to minus reaction. Action is equal to minus reaction. Remember that. Action is equal to minus reaction. So opposite direction it will be acts. That's why we can consider this one. So, for example, gun. So when a gun is fired, the gun applies force on the bullet and hence the bullet moves forward. According to the third law, bullet also applies the same force on the gun in opposite direction. This force gives back kick to the gun. That's why compulsory to that gun to attach these shoulders, to apply this shoulder, then only to be fired, because the force will be some force. When bullet releases from the gun, that bullet goes out and some force will be pushes the back. So suppose you will keep like this, it come and touches this spot, so it is very dangerous. That's why compulsory, that is called recoil of the gun. This situation is also said to be the recoil, compulsory to push that gun to this shoulder. And one more example to consider. When two vehicles collide with each other, the force applied by the first vehicle causes damage to the second vehicle. According to the third law, the second vehicle also applies the same force on the first vehicle. This reaction force causes the damage on the first vehicle. When two vehicles to be in an accident, to had observed this, two will be clash. What happens? First one applies force on second body, the second one also applies certain force on the first one. So two forces will be acts here, but in opposite directions. So I had considered gravitational unit of force. This will become in next chapter also. Then next we can discuss about that. Here we can discuss momentum by application of action equal to minus reaction. We have to define one important law, that's said to be the law of conservation of momentum. Law of conservation of momentum. This applies on this third law of motion. So by that we can consider this law of conservation of momentum. Law of conservation of momentum. Remember that this is a very important law. By this action and reaction, after knowing these forces, we can apply this law. This law of conservation of momentum. So this third application, due to that only rockets, toy rockets or otherwise real rockets also be moved by this Newton's third law. Remember that jet speed, the jet planes, etc. also be moving by this Newton's third law of motion. Okay, so this is all the applications. So sometimes among the following, which can act the Newton's third law, such a questions will begin. And then to observe jet planes. Jet planes will act Newton's third law rocket or jet planes. On that we can apply this Newton's third law. Now we can discuss about this law of conservation of momentum. So this law of conservation of momentum also be very important one. So momentum means we know here that's conservation of two forces will be acts on that opposite and equal forces. We get this conservation of momentum application. What is this conservation of momentum means? M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2 is said to be the Newton's second law, law of conservation of momentum. M1 U1 plus M2 U2 is equal to M1 V1 plus M2 V2 is said to be the how we get this application, that can also we have to see. So that application, to remember, m1 u1 plus m2 u2 is equal to m1 v1. So here initial momentum, sum of the initial momentum of the bodies is equal to the sum of the final momentums of the body. So by that we can apply, we can get this application. m1 u1 plus m2 u2 is equal to m1 v1 plus m2 v2. Now to show mass and weight both will be the same quantities, means there is a some difference between mass and weight. Both are not same. Mass of the body, weight of the body is not same. Like for what is that? Speed and velocity, or distance and displacement. Like that, this can also be varies. What is that? Mass and weight. Weight of the body is different from mass of the body. So mass. Next, continue in next topic.